Okay, let's take a look at number 13 in section 5.4. Pretty quick one. We're going to evaluate using FTC1. Remember that stands for the Fundamental Theorem of Calculus Part 1. So we're looking at this definite integral from 1 to 7, and this is the way they wrote it, 5 times dt over t squared. So just a little reminder, this 5 is a constant multiple, so I'll pull it outside the integral sign using the linearity properties that we can use. And then dt over t squared really is the same as 1 over t squared dt. In other words, this is the function we are integrating, what we're finding the antiderivative of. The dt sometimes will creep up in there. That's like we're multiplying by this dt, but again, dt is telling us the variable of integration is t. It's not a particular quantity per se, right? It's like treated as equal to 1, if you will. But this is the actual function we're integrating. To do this, though, right, we've got to rewrite. I can't just say, oh, the antiderivative of t squared is 1/3 t cubed, so it's 1 over 1/3 t cubed. No, right? That's not the power rule. I need to write this as t to some power, and that is t to the -2. So make sure you understand, again, what negative exponents, represent. So now I can use the power rule, right? The integral of t to the n, right, is going to be t to the n plus 1 divided by n plus 1, right? So I'm going to let n, in this case, be -2, and be careful when I add 1 to -2, I get -1, not -3, so be careful, right? So it's t to the n plus 1 divided by n plus 1. Let's clean this up a little bit. T to the -1 is 1 over t, and 5 divided by -1 is -5, so I get -5 divided by t. Again, I'm going to evaluate this at the upper limit of 7, lower limit of 1. When I plug in 7, I get -5/7 minus, when I plug in 1, -5 divided by 1, I get a -5. So be careful here. This actually becomes +5. And then I can write this as a fraction. That's what they want. 5 is 35/7. -5 plus 35 is 30. So we get 30/7 as our result. Okay, hope this helps.